Hi everyone, welcome back to Technical Mathematics. In lecture 15, we will be discussing set 2 of multiple choice questions related to trigonometric functions. I invite you to solve problems on the go and check the solutions given in this video. So take a pen and paper, let's get started. Problem number 1. Find the principal value of sine inverse of minus root 3 by 2. So we are asked to calculate the value of sine inverse of minus root 3 by 2. So you may try to solve this by yourself. Please pause the video and try to solve this by yourself. Okay, now coming to the solution. To solve this problem, we should know one equation, that is sine inverse of minus x is equal to minus of sine inverse of x. So let's try to make use of this formula here. What we have here is sine inverse of minus root 3 by 2. So sine inverse of minus root 3 by 2 shall be written as minus of sine inverse of root 3 by 2. Okay, and we know that sine inverse of root 3 by 2, it is nothing but 60 degree or pi by 3. So we shall rewrite it as minus of pi by 3. Okay, so that is the answer, minus pi by 3. So here the right answer is given by option B. Okay, now let's move on to problem number 2. Now let's try to solve one PSC exam question. Find the value of 2 into tan inverse of 1 plus tan inverse of 2 plus tan inverse of 3. Okay, so here the first part, it is 2 into tan inverse of 1. We know what is tan inverse of 1. Tan inverse of 1 is pi by 4. Okay, so let's rewrite it as 2 into pi by 4 plus, then the second part is having tan inverse of 2 plus tan inverse of 3. Okay, and this is in the form tan inverse of x plus tan inverse of y. So it is in the form tan inverse of x plus tan inverse of y. Okay, so let's see the equations corresponding to tan inverse of x plus tan inverse of y. Okay, so we have three equations corresponding to tan inverse of x plus tan inverse of y, and let's see which one is appropriate in our case. Okay, in our case the value of x is 2 and the value of y is 3. Okay, and here the first equation says that tan inverse of x plus tan inverse of y will be equal to tan inverse of x plus y divided by 1 minus x into y. Okay, so this equation is applicable when x into y is less than 1. Okay, in our case x into y will be 2 into 3, that is 6, and it is greater than 1. So we are not going to use the first equation. Okay, now the second equation goes like this: tan inverse of x plus tan inverse of y is equal to pi plus tan inverse of x plus y divided by 1 minus xy. Okay, and we will be using this equation when x value is greater than 0, y value is greater than 0, and the product x into y is greater than 1. Okay, so in our case x is greater than 0, it is 2, y is 3, therefore it is greater than 0, and the product x into y, it is 6, and that is found to be greater than 1. Okay, so all the conditions corresponding to the second equation is applicable in our case, so we will be using this second equation. Okay, now let's see the third equation. The third equation is applicable when x is less than 0, y is less than 0, and the product x into y is greater than 1. Okay, in our case x and y values are greater than 0, therefore this equation is also not applicable in our case. So we will be using this second formula to solve our problem, that is tan inverse of x plus tan inverse of y equal to pi plus tan inverse of x plus y divided by 1 minus x into y. Okay, now let's go back to our problem. So here we have tan inverse of 2 plus tan inverse of 3, and let's rewrite it as pi plus tan inverse of 2 plus 3 divided by 1 minus 2 into 3. Okay, now once we simplify this, we will be getting it as 2 into pi by 4 plus pi plus tan inverse of, here we have 2 plus 3, that is 5. Okay, so numerator term will be 5, and in the denominator we have 1 minus 2 into 3, that is 1 minus 6, so that is minus 5. So 5 by minus 5, we will get it as minus 1. Okay, so the expression reduces to 2 into pi by 4 plus pi plus tan inverse of minus 1. Okay, and we know that tan inverse of minus x is nothing but minus of tan inverse of x. So therefore, let's reduce tan inverse of minus 1 as minus tan inverse of 1. Okay, so we will rewrite this entire expression as 2 into pi by 4 plus pi minus tan inverse of 1. Okay, and we know what is tan inverse of 1, it is nothing but pi by 4. Okay, so this will be equal to 2 into pi by 4 plus pi minus pi by 4. Okay, and this pi minus pi by 4, it's nothing but 3 pi by 4. Okay, so this will be 3 pi by 4. Okay, and here we have 2 pi by 4, that is added with 3 pi by 4 to get the final result as 5 pi by 4. So here the right answer is given by none of the options what we have here. Okay, the right answer is 5 pi by 4, and we will be getting this answer when we use this second equation, okay, which is satisfying the condition x greater than 0, y greater than 0, and x into y greater than 1. Instead, if we are using this first equation what we have here, okay, you will be getting the answer as option B, pi by 4. Okay, but that is not the valid equation that we have to use here. In our case, the value of x is 2 and the value of y is 3. So the appropriate equation is the second equation, and if we use the second equation, we will get the result as 5 pi by 4. Okay. Now let's move on to problem number 3. Maximum value of 2 cos theta plus 3 sin theta is. Okay, we are asked to calculate the maximum value of 2 cos theta plus 3 sin theta. Okay, so you may pause the video and try to solve this by yourself. Okay, now let's see how to solve this problem. So here this expression 2 cos theta plus 3 sin theta is in the form a sin theta plus b cos theta. Okay, and the maximum value corresponding to this expression is, the maximum value is equal to plus root over a square plus b square. Okay, and the minimum value will be minus root over a square plus b square. Okay, so in this problem we are asked to calculate the maximum value, so we will use this formula to solve this problem. Okay, so here maximum value will be equal to root over, here coefficient of sin theta is 3, so 3 square, that is 9, plus coefficient of cos theta is 2, that is 2 square, that is 4. So the maximum value will be root over 13. Okay, and that is given by option C here. Okay, so right answer is root 13. Okay, now let's see problem number 4. The greatest value of sine raised to 4 theta plus cos raised to 4 theta is. We are asked to calculate the greatest value of sine raised to 4 theta plus cos raised to 4 theta. Okay, so you may try this by yourself. Please pause the video and try to solve this. Okay, now coming to the solution, here we are asked to calculate the value of sine raised to 4 theta plus cos raised to 4 theta, the greatest value corresponding to sine raised to 4 theta plus cos raised to 4 theta. Okay, now we know that sine square theta plus cos square theta, it's equal to 1. Okay, let's square on both sides of this equation. If we square on both sides, what we get on left hand side will be sine raised to 4 theta plus 2 into sine square theta into cos square theta plus cos raised to 4 theta equal to 1. Okay, right? So squaring on both sides, we will get the equation like this. Okay, now let's take this second term to the right hand side. So we will get it as sine raised to 4 theta plus cos raised to 4 theta equal to 1 minus 2 sine square theta into cos square theta. Okay, so this expression will be taking the maximum value when this term takes the minimum value. Okay, but here we have two square terms. Okay, so they cannot be negative. Okay, so if they become positive, then the entire value on right hand side will be less than 1. Okay, so the right hand side will have the maximum value when this expression reduces to 0. Okay, and that can happen at two theta values, when theta equal to 90 degree or when theta is equal to 0 degree. This expression can reduce to 0. Okay, so anyway, the maximum value on right hand side will be occurring when this expression reduces to the minimum value. The second term what we have here, when it reduces to the minimum value, we will have the maximum value for RHS or right hand side. Okay, so this expression cannot be negative because we are having two square terms here. So the minimum value that this second term on right hand side can take is 0. Okay, so when this goes as 0, right hand side will reduce to 1, and that is the maximum value possible for this expression on left hand side. So therefore here the right answer will be given by option D, that is 1. Okay, now let's see problem number 5. If cos pi x is equal to x square minus x plus 5 by 4, then the value of x will be. Okay, to solve this, let's consider the right hand side. The right hand side is like this: x square minus x plus 5 by 4. Okay, let's rewrite this expression as x square minus 2 into x into 1 by 2. Okay, so let's multiply x with 2. To nullify that, we will multiply x again with 1 by 2. Okay, then here we have plus 1 by 4 minus 1 by 4. Okay, so we are adding a plus 1 by 4 here. To nullify that, we are putting a minus 1 by 4 here. Okay, then we have plus 5 by 4. Okay, now this part, okay, this part what we have here can be replaced with x minus 1 by 2 whole square. Okay, this one plus, here we have minus 1 by 4 plus 5 by 4. So that will reduce to 4 by 4 and we get it as 1. Okay, so the value of cos pi x, okay, it is nothing but x minus 1 by 2 whole square plus 1. Okay, now if you substitute x values from these options here, you can see that when you substitute 0 here, you will be getting a value which is greater than 1. When you substitute x equal to 1 here, again you will be getting a value which is greater than 1. And when you substitute minus 1 here, again you can see that you will be getting a value which is greater than 1. Okay, here on left hand side what we have is cos pi x. Okay, so we know that the value of cos theta, it lies between minus 1 and plus 1. Okay, so it can never go greater than 1. Okay, so if you substitute any of these options here, if you substitute any of the x values given here in this equation, you will get cos pi x greater than 1. So all these options A, B, C are invalid, or the values given by these options do not satisfy this equation. So therefore here the right answer is none of the above, that is option D. Okay, now let's move on to problem number 6. If sine pi x by 2 is equal to x square minus 2x plus 2, then the value of x will be. So we have to find out the x value which satisfies this equation. Okay, so you may try to solve this by yourself. Please pause the video and try to solve this. Okay, so to solve this, we may randomly substitute the values given by the four options here. If you substitute 0 here, what we get on left hand side will be sine 0. We know sine 0 is equal to 0. But on right hand side, you will be getting 0 minus 0 plus 2. So our RHS will be 2. Okay, so corresponding to option A, LHS value will be nothing but 0, okay, but RHS value will be nothing but 2. Okay, so this value is not valid, okay, or this value 0 does not satisfy this equation. Okay, now let's substitute x equal to 1 here. Okay, so when you substitute x equal to 1 here, we get sine pi by 2 on left hand side. Okay, when we substitute x equal to 1 here, we get sine pi by 2 on left hand side, and we know that sine pi by 2 is 1. So LHS value will be equal to 1 when you substitute x equal to 1 here. Okay, correspondingly the right hand side will be 1 square minus 2 into 1 plus 2. So that is 1 minus 2 plus 2. So minus 2 and plus 2 will be getting cancelled. You will be getting 1 square. So RHS will be nothing but 1. RHS will be 1. So option B satisfies this equation. Okay. Now if you substitute x equal to minus 1 and x equal to 1 by 2, you can see that this equation is not held true. Okay. So therefore here the right answer is given by option B, that is 1. Now let's see problem number 7. If theta is an acute angle and 7 sine square theta plus 3 cos square theta is equal to 4, then the value of tan theta is. So we are asked to calculate the value of tan theta. Okay, so please pause the video and try to solve this by yourself. Okay, now coming to the solution, we are given that 7 sine square theta plus 3 cos square theta is equal to 4. Okay, so let's rewrite this expression like this. 4 sine square theta plus 3 sine square theta plus 3 cos square theta equal to 4. Okay, now here we have 3 common in both these two terms, so let's combine those two. So 4 into sine square theta plus 3 into sine square theta plus cos square theta, that will be equal to 4. Okay, now we know that sine square theta plus cos square theta is equal to 1, so left hand side can be rewritten as 4 sine square theta plus 3. Okay, and that will be equal to 4. Okay, now let's simplify this. Take this 3 to the right hand side, so we will get it as 4 sine square theta equal to 1. Okay, so this implies that sine square theta is equal to 1 by 4. Okay, now let's take square root on both left hand side and right hand side. So this will reduce to sine theta, this will reduce to sine theta equal to 1 by 2. Okay, so sine theta is equal to 1 by 2 is valid when theta is equal to pi by 6, that is 30 degree. Okay, and we are asked to calculate the value of tan theta. So tan pi by 6 or tan 30 degree is nothing but 1 by root 3. So here the right answer is given by option D, 1 by root 3. Now let's see problem number 8. The simplified value of sec a minus cos a whole square plus cosec a minus sin a whole square minus cot a minus tan a whole square is. Okay, you may try to solve this by yourself. Please pause the video and try to solve it. Okay, now coming to its solution, let's expand these 3 terms. Okay, so when you expand the first term, you will get it as sec square a plus cos square a minus 2 sec a into cos a. Okay, then plus the second term is cosec a minus sin a whole square. Let's expand that. So what we get is cosec square a plus sin square a minus 2 into cosec a into sin a. Okay, then minus, let's expand the third term. When you do that, we get it as cot square a plus tan square a minus 2 cot a into tan a. Okay, now here we have sec a into cos a, that will reduce to 1. Here we have cosec A into sin A, that too will become 1. Here we have cot A into tan A, that also will be 1. Okay, so let's try to simplify this. We will get it as sec square A plus cos square A minus 2 plus cosec square A plus sine square A minus 2. Okay, here we have minus of cot square A plus tan square A minus 2 into cot A into tan A. So this cot A into tan A will become 1. So here we will get it as minus cot square A minus tan square A plus 2. Okay, so here we have minus 2, here also we have minus 2, here we have plus 2, so these two 2's can be cancelled. Okay, then here we have cos square A, here we have sine square A, so when you add up those two you will get 1. Then here we have sec square A, here we have minus tan square A. Okay, when we combine those two we will get 1. Okay, then here we have cosecant square A, then we have minus cot square A here. So when you combine these two, you will get another one. Okay, so let's do that. We may rewrite this expression as sec square A minus tan square A. Okay, plus here we have cosec square A, here we have minus cot square A. So cosec square A minus cot square A, then plus here we have cos square A, here we have sine square A. So let's combine those two, cos square A plus sine square A. Okay, then here we have a minus 2 left out, so minus 2 here. Okay, now we know that sec square A minus tan square A is 1, cosec square A minus cot square is again 1, then we have cos square A plus sine square A, that too is 1. So we get 1 plus 1 plus 1 minus 2. Okay, so 1 plus 1 plus 1 minus 2, the final answer is 1. 3 minus 2, that is 1. So here the right answer is given by option C, that is 1. Now let's see problem number 9. Evaluate sec square A plus 1 plus tan A into 1 minus tan A. Okay, you may try to solve this by yourself. Please pause the video and try to solve it. Okay, now coming to the solution, let's rewrite this expression as sec square A plus 1 minus tan square A. So this is in the form A plus B into A minus B. So that is equal to A square minus B square. So we may rewrite this second part as 1 minus or 1 square minus tan square A. Okay, now this can be replaced as sec square A minus tan square A plus 1. Okay, and we know that sec square A minus tan square A is 1. So 1 plus 1, we will get the final answer as 2. Okay, so here the right answer is given by option C. Problem number 10. Find the correct trigonometric identity. So we are given 4 expressions here. You have to find out the right one. Okay, so just pause the video and think about the answer. So here the right answer is given by option A, that is tan square theta is equal to sec square theta minus 1. Okay, so we know that sec square theta minus tan square theta is equal to 1. Okay, so this expression is just rewritten like this, tan square theta equal to sec square theta minus 1. Okay, so here the right answer is given by option A. Okay, so with this we are coming to end of lecture 15. In lecture 16 we will start with coordinate geometry. Okay, so for upcoming videos you may subscribe to our channel Vadhyar Online Academy on YouTube, and you may subscribe to our Telegram channel using this link to receive study materials. So see you in lecture 16. Goodbye.